Hello, this is Mr. Collier, and today we're looking at the scalar product, also called the dot product. Okay, so let's take a look at this triangle here and how we get the distance AB. So we can use cosine rule for that, and then I'll show you what the dot product is. So let's call this angle theta, and according to the cosine rule, we can say the distance AB squared equals a squared plus b squared minus 2 times the magnitude of a, magnitude of b, cosine theta. Okay, so let's now if we let the vector a be a1, a2, and vector b be b1, b2, and we'll substitute all that in. So to get ab, we do head minus tail, so we do b minus a, and that means we do, so we'll have the vector b1 minus a1, and b2 minus a2. Okay, so that's how we calculate ab, the vector ab. And over here, the magnitude of this is just square root of a1 squared plus b1 squared, and this is all squared, so the square roots will cancel. Then we're going to have, so that should be a b1 squared plus b2 squared. Okay, and over here I'm going to leave these the same, and cosine theta. Okay, so here, when we get the magnitude, that's going to be root b1 minus a1 squared plus b2 minus a2 squared. And here the squares and square roots cancel, so we're going to have a1 squared plus a2 squared plus b1 squared plus b2 squared minus, I'll just copy this the same. Okay, so the square and the square root cancel here, and I'm going to expand these now. So you're going to have b1 squared, you're going to have a minus 2a1 b1 plus a1 squared, and here you're going to have b2 squared minus 2a2 b2 squared. Plus a2 squared equals, and the same thing over here. Notice now that we got b1 squared and a b1 squared on both sides, and all these squared terms will cancel. Okay, so we're left with negative 2a1 b1 minus 2a2 b2 minus 2a magnitude of a, magnitude of b, cosine theta. So that's an equals there, right? So we divide both sides by 2, and we have a1 b1 plus a2 b2 equals magnitude of a, magnitude of b, cosine theta. Okay, and I believe that's the way one of the formulas look in the formula booklet. So that's this one here. Okay, you can do it for three-dimensional vectors as well, and you can rearrange to solve. You have cosine theta equals a1 b1 plus a2 b2 over magnitude of a times magnitude of b. Okay, so this is, I guess, is useful for finding angles between two vectors, and we often call this thing on the top, we refer to this as the dot product. Okay, so dot product is just a term for this, right? So we call that so we call that a dot b. So it's just shorthand notation for this, right? So if you look at the formula booklet, you'll see here's a definition of dot product, which is exactly what we just did, right? Okay, so let's take a look at the next one here. So this should be a dot in between, so a dot b equals a1 b1 plus a1 b2. Okay, that's what we just proved, right? This is a rule from the formula booklet. There's two main uses for a scalar product or dot product: to find an angle between two vectors and to show that they're perpendicular. Okay, so if we look at our formula from before, we've got a fraction here. If the numerator equals 0, then we have cosine theta equals 0, so the angle is going to be 90 degrees. So the angle between two vectors is 90 degrees when the dot product equals 0. So that's a useful little property. Okay, so find the angle between these two. Well, we're going to use this rule, rearrange cosine theta equals, let's call this u and v. And I'll say u dot v over magnitude of u, magnitude of v, right? Is cosine theta. This equals, so to get the dot product, we do 1 times 2 plus 3 times negative 1 is the dot product. And on the bottom, we're going to get the magnitude, so this is 1 squared plus 3 squared, 2 squared plus negative 1 squared. Okay, so we have 2 minus negative 1. And here we've got 9 tenths, so that's root 10. And this is root 5. Okay, so theta equals arc cosine negative 1 over root 10 root 5. So let's check out what that is on our calculator. And usually when we do vectors, we usually use degrees for our angles. Okay, so let's do inverse cosine negative 1 divided by root, I guess you could say this is root 50. Oops. Let's try that again. Root 50. Okay, we get 98.1 degrees. Okay, let's look at next question. Find the angle at A in the triangle whose coordinates are given by these. Okay, so let's set it up. Here's A is 2, negative 1. B is 3, 2. And C is 4, 3. So we want to get this angle right here. Okay, so cosine theta. Now we need these vectors. Okay, so cosine theta is going to be equal to vector AB dot product with AC over the magnitude of AB times the magnitude of AC. So we need to get AB and AC first. So let's do that over on the side. AB, so AB is head minus tail, so B minus A. And remember the x values first, so 3 minus 2 is 1. And 2 minus negative 1 is 3. And then AC is 4 minus 2 is 2. 3 minus negative 1 is 4. Okay, so then let's plug that into the formula over here. We have this dot product is going to be 1 times 2, which is 2, plus 3 times 4, which is 12, and over the magnitude of these vectors. So we got 1 squared plus 3 squared, 2 squared plus 4 squared. So we'll have 14 over root 10, root, we got 16 plus 4 is 20. So it is 14 over root 200. Okay, so theta equals arc cosine of that. Let's type that into the calculator. Okay, arc cosine of 14. Oops. Over root 200. Okay, and we get 8. 90.13 degrees. Okay, like I previously mentioned, if two vectors are perpendicular, the angle between them is 90, of course, and that means that their dot product is going to be 0. So find k if these two vectors are perpendicular. So that means that 2, -1 dot k4 is going to be equal to 0. So then we get this simple equation: 2k minus 4 equals 0, 2k equals 4, and k equals 2. Okay, the next example, we're going to find the angle between two vectors in 3D. Okay, so we're going to have cosine theta equals, and I'll do the dot product on the top, is 2 minus 2 plus 4. And we're going to have root 1 squared plus 2 squared plus 4 squared, root 2 squared plus -1 squared plus 1 squared. And that's going to give me 4 over root 21, root 4 plus 2 is 6. Okay, so theta, let's use our calculator again. We got inverse cosine 4 divided by root 21 times 6. And we get 69.1 degrees. Okay, the next example, find k given that these two vectors are perpendicular. So again, we'll just set the dot product equal to 0. So 0 equals 4k minus 1 plus 1, and then we just get 4k equals 0, so k equals 0. And in the next example, find the angle A for the this triangle here, and this is similar to the example we saw before. Okay, so let's draw a sketch. A, B, C, 0, 2, 3. We have 1, 4, 2, and 2, -1, 0, and we need to find AB and AC. So AB is 1 minus 0 is 1, 4 minus 2 is 2, 2 minus 3 is -1, and AC equals 2 minus 0 is 2, -1 minus 2 is -3, 0 minus 3 is -3. Okay, so we have cosine theta equals the dot product, which is 2 minus 6 plus 4 over root 2 squared, over root 1 squared plus 2 squared plus -1 squared, root 2 squared plus 3 squared plus 3 squared. So in the numerator, we get, I guess I didn't need to do all the stuff on the bottom, is in the numerator we get 0. Okay, so we got 0 overall, so that's cosine theta equals 0, so therefore theta is 90 degrees.